Okay, good morning, class. We are going to talk about healthy eating and food safety today. Okay, that's the outline of today's class. We will talk about phytonutrients and plant pigments, and colors in meat, poultry, and fish. Then we will talk about pollutants in food and foodborne carcinogens. The GMOs and safety regulation, organic foods and nutrition. Lastly, we'll talk about microwave heating and radiation. We have been emphasizing on plant-based diet. So this is the classification of plant-based foods that includes seeds, herbs, spices, vegetables, any part of the plant eaten for food. So that's a general term. Fruits, nuts. So this is a whole grain kernel. It has the bran, endosperm, and germ. So the germ is the storage of nutrients. So it has the anti-nutrients to lock in the nutrients before the green sprouts. So when we soak and let the green sprouts, then it becomes a sprouted grain. During sprouting, enzymes are activated to break down anti-nutrients so that nutrients locked in the germ are released. So sprouting improves nutrition of grains and seeds. So here are the sprouted wheat flour and sprouted grain bread that are available on the market. So sprouted grains, it's the greens that are sprouted, but then the sprout growth should not exceed the kernel length. So as long as the sprout is not longer than the kernel length, so we will consider it as sprouted greens. There are different types of flour. Commonly, we have 4 types. The cake or pastry flour has lower protein content. So the protein in wheat, it's the majority is gluten. So that cake and pastry flour has lower gluten content. All-purpose flour has medium protein content, and bread flour has the highest, had a higher protein content. So it's like when we make bread out of bread flour, it's less tender because there are more gluten development, and it's the gluten made the bread chewy. A whole grain, it has high protein content, and it also has more nutrients and fiber. But when we use the whole wheat flour to make bread, then the bread has the crumbly texture because the fiber tells the gluten, like to break down the gluten strains. So the fiber prevents gluten development, and also the bread made out of whole wheat tend to be heavier, so you can tell by just feel the bread in your hand. So we want to eat a good variety of foods. So for the plants, you want to eat a rainbow, all the different colors. But different colors usually indicate different types of plant nutrients or phytonutrients. And different phytonutrients have different health benefits. There's 3 types of plant pigments: carotenoids, chlorophyll, and flavonoids. Carotenoids give the plant, usually the fruits or the vegetables, a yellow-orange color. Lycopene is a red-orange color. And chlorophyll, of course, gives the green colors in plants. So all the green leafy vegetables have lots of chlorophyll. Broccoli, green cabbage, kale, lettuce, spinach. And flavonoids, that's the most colorful plant pigments. Anthocyanin gives the bright red-purple color in eggplants, radish, red cabbage, red potatoes. Anthocyanin, it's the cream white color in cauliflowers, onions, rice, white potatoes. And that's the flavonoid anthocyanins. So anthocyanins, it's the plant pigment complex with sugar. And the color is more intense when it's complex with sugar. So it's like blue, purple, violet, and magenta, and red colors. The anthocyanins have very important impact on color, flavor, and astringency of fruits. It's highly sensitive to pH. Here's the pH from low pH to higher pH. So an acidic pH, it's like bright in like orange, red, more red. And at higher pH in alkaline, it's more purple. Anthocyanins also has this characteristic, like when it encounter, like meets the metal, like when we use metal knives or containers, there will be undesirable color changes. So it turns the red purple into green and bluish. So try not to use metal utensils or containers for the colorful fruits and vegetables, especially during heating and storage. The anthocyanin, the white and cream yellow color in fruits and vegetables, it has more oxygen, but the impact on food's color is more subtle. And it contributes the flavor of food. And it also has this slight color change with pH. When it has an acid pH, it has a bleaching effect, so it's more white. And in alkaline pH, it's a subtle yellow. And it also reacts with metal. And when anthocyanin it's under excessive heat or it's exposed in the air, it's going through some changes too. So that's color changes with pH and oxidation. the browning reactions of anthocyanin, it's very, like it's widely in fruits and vegetables. Here is an example of the apples. When apples are cut, you see it's the cream yellow color, but when you leave them in the air, then it will become this brownish color. So it's just undesirable. That's because the enzyme polyphenol oxidase, like oxidize the anthocyanin. So it occurs in not just apples, also mushrooms, potatoes, bananas, pears, peaches too. Then how do we prevent this? Like for the vegetables, like potatoes and cauliflowers, can do a quick branch in water to denature the enzyme, this enzyme polyphenol oxidase. When it's deactivated, then it will prevent this browning reaction. And we can also coat like apple, the cut apple with acid. So it will interfere with the enzyme activity. Or soak in water, that's what you usually do with potatoes. As soon as you cut the potato, just put them in water and chill in lower temperature, just like in the refrigerator, or coat with sugar and syrup. This is same with water, like as barriers from oxygen to react. And treat with antioxidants that prevents oxidation. As usually during prolonged storage, like adding sulfur ascorbic acid, that's the vitamin C. And then lemon can prevent browning too. So after you cut an apple, you just drop some fresh lemon juice on it, and it will stay fresh looking. The chlorophyll changes during heating too. So that's the raw broccoli, it's green. But for this after branching in boiling water, it becomes more vivid. The green color become brighter. But during prolonged cooking, if you leave the broccoli on the oven for too long, then the color will change to this undesirable greenish gray or olive color. It's because the magnesium in the center of chlorophyll is lost and replaced with hydrogen. So when we cook vegetables too long, we will lose magnesium and the green vegetables. So meat and poultry pigments, the two main pigments in meat are hemoglobin and myoglobin. Hemoglobin and myoglobin are both iron containing protein. So hemoglobin, this is myoglobin. Myoglobin carries oxygen in skeletal muscle. Hemoglobin carries oxygen in blood and in our red blood cells. So that is both hemoglobin and myoglobins are iron-containing pigments with heme. This is the heme, this is the iron in the center. So in red meat, the most prominent pigment is myoglobin. And in poultry, the color is lighter than red meat. It's due to less, the color is from hemoglobin, because poultry has less myoglobin. So most lighter red color in poultry is due to the presence of hemoglobin. And fish. The fish flesh color is also due to hemoglobin and myoglobin. So that the different combination of hemoglobin and myoglobin in fish will give different shapes of the red color. And some seafood like salmon, and that's lobster and shrimp, has this reddish orange color. That's due to astaxanthin. Astaxanthin, it's also a carotenoid. Now let's look at carcinogens in food. So the carcinogens in food can be formed during processing or during cooking, and can also be formed in our body. And the animal sourced carcinogens, including heme iron, and that's the heterocyclic aromatic amines, and polycyclic aromatic hydrocarbons. So these two are the most common, PHAs, HCAs. And plant-sourced carcinogens, the acrylamide during heating, like overheat, and mycotoxins in food. We'll talk about that later. And pesticides and insecticides and heavy metals. Heavy metals like this, like lead, mercury. We'll talk about arsenic. But let's look at aflatoxins in food chain. So aflatoxins can be they can be can be accumulated during pre-harvest, like the growing of the plants, or during post-harvest, storage and transportation. The aflatoxins are produced by fungi. So like fungi contamination in food lead to the production of aflatoxins. So the aflatoxins, like in corn, that's very common, and peanuts. So these two are the most susceptible foods that we tend to eat a lot, the corn. And the corn can also be used as animal feed. So when the animals consume feed that's made out of the contaminated corn, like the chickens too. So that's then the aflatoxins can be found in animal products like milk and eggs, also in peanut derived product like peanut butter. So then it will enter our human body after consumption. Arsenic is a great concern, like for lung cancer and bladder cancer. It's a risk factor for lung cancer and bladder cancer. So arsenic is found in rice, because rice is grown under flooded conditions, and this contributes to arsenic content in bran. So there's the white rice, especially in brown rice, because brown rice still has the bran. And risk of cancer and consumption, the serving frequency of white rice is dose dependent. So the more servings one consumes during a week, the higher the risk of cancer. And that's the cancer risk is lifetime. So like for a child that consume lots of white rice from age 0 to 6, so before age 6, the cancer risk is lifetime increased. So it has prolonged lifelong impact. Now, how do we lower the intake of arsenic? Like diet choices. White rice, it really have lower arsenic than brown rice because arsenic is mostly found in bran, and brown rice still has a bran. But then brown rice has higher nutrition value than white rice. So let's need to weigh the benefits and harms. But for children under age of 6, it's best not to eat white rice or white rice derived products, especially for infants. That's because for children, they eat like up to 3 times more food, like compared to and relative to the body weight than adults. So children need to take less white rice and brown rice products. And look for rice from regions have less, like a lower arsenic. Basmati rice from California, India, and Pakistan usually have lower arsenic content. And can replace white rice with lower arsenic grains such as millet, quinoa, oats, and corns. Just for the infants and babies, choose snacks that are made out of the other greens, not made out of rice. And check the labels of the snack to see if they are made up with rice or rice flour. And cooking, rinse rice really well before cooking. With rinsing rice with lots of water will reduce the arsenic concentration because the arsenic will be rinsed out with the water. And cook the rice like we cook pastas, because when we cook pasta, we use much more water and then drain the water after the cooking is finished. The carcinogens generated during food processing, these are like this nitrous compounds, PHAs and HCH. These are the polycyclic aromatic hydrocarbons. And HCH is a heterocyclic aromatic. So those all have this aromatic ring. So food processing, like during curing, heating, and smoking, meal preparation, like baking, frying, grilling, all this involved high heat, like a very high temperature, and very high temperature make the generate these compounds, the dietary carcinogens, like acrylamide. So how do we reduce is carcinogens in cooked meat by avoiding direct exposure of meat to an open flame or hot metal surface. That's like grilling. Because grilling could be just like put a meat right on top of the open flame or on a very hot metal surface. So we need to avoid that, eat less grilling meat. And avoiding prolonged cooking time. So just try to reduce high temperature cooking time. and use a microwave oven to cook meat prior to exposure to high temperatures. That will help reduce the time the meat will be in contact with the high heat. And turn meat over continuously so that it's not going to expose to the open flame or hot metal surface constantly. And remove charred portion of meat. So if already overheat and burnt, we want to remove the portion. And refrain from using gravy made from meat drippings. The persistent organic pollutants, these are the true dirty dozen. So most of the insecticides, pesticides, and herbicides. And some of them are byproducts of the industrial byproducts, like combustion. So that pollutants can enter human body through the air we breathe, the water we drink, or the food we eat. The other major type of the pollutants, it's from plastics. So the plastic additives as xenoestrogens. So they are in the form of xenoestrogens. This is the chemical estrogens. So this is the human cell, and that's a estrogen receptor. So when the estrogen binds to the receptor, it's like reversible. And when estrogen binds to estrogen receptor, it stimulates self-growth. But then this binding and the self-growth is in response to the signals we receive, and it's reversible. That xenoestrogens bind to estrogen receptors on cells too, but the binding is irreversible. So once xenoestrogen binds to estrogen receptor, then it will stimulate signal transduction, but it's unintended signals that then lead to overstimulation of the cell, leads to uncontrolled self-growth. And uncontrolled self-growth, it's the step will lead to cancerous growth, the major risk. So these are the plastics that could potentially contain the xenoestrogens. A lot of them is household products. So again, let's say xenoestrogens overstimulate self-growth and promote cancer progression. And phytoestrogens, the estrogens from plants. Phytoestrogens bind to estrogen receptor, but it's bind to estrogen receptor beta subunit. Xenoestrogen binds to estrogen receptor alpha subunit, like ER alpha, and phytoestrogens binds to ER beta. Like the body estrogen binds to both estrogen receptor alpha and beta. So phytoestrogens binds to estrogen receptor beta, and it's actually compete with the binding with estrogen receptor alpha. So phytoestrogens could inhibit cancer progression. And also phytoestrogens has the anti-inflammatory property, so that this can help to inhibit tumor progression. So suppress tumor development and tumor progression. We will talk about cancer prevention in the next class. So that's we need to pay attention to recycling symbols on plastics that are different numbers, usually on the bottom of the plastic containers. So there are different numbers, 1, 2, 3, 4, 5, 6, 7. Now BPA-free containers are made from 1, 2, 4, 5 plastics. And number 3, 6 have this high chance of containing BPA, xenoestrogens. And number 7, it's polycarbonate and other plastics, so it could have a BPA too. So how to avoid BPA, bisphenol A, that's BPA. So use reusable shopping bags for groceries, bring your own mug for coffee, and bring drinking water from home in glass water bottles or stainless steel water bottles. So try not to buy bottled water in plastics. And store foods in the freezer in glass mason jars. Take your own non-plastic containers to restaurants for leftovers. And request no plastic wrap. We don't use this newspaper anymore. Avoid disposable utensils. That you may also want to bring your own utensils to restaurants. And buy foods in bulk to reduce plastic packaging. Replace plastic kitchenware with glass or ceramic alternatives. And buy and eat fresh whole foods. We have been really emphasizing on fresh whole foods, reduce packaged and canned foods, and use stainless steel high heat resistant nylon for utensils instead of plastics, and skip paper receipts. If you scratch the back of receipt and you see this like kind of like black, then it contains BPA. Nowadays, most of the receipts don't have, not made with BPA anymore. And wash hands after handling receipts and CDs, toys. And household products, try to use eco-friendly biodegradable cleansers, like baking soda, vinegar, and lemon juice. It's a very good cleaning agent. And you may also use the stream. So that cleans very well too. So try to avoid using those chemicals too in house. Okay, organic foods, the foods that are grown and processed, using government regulated farming methods to meet USDA, US Department of Agriculture organic standards. And these are the standards for organic farming and processing. So no synthetic fertilizers or pesticides. Of course, there are some exceptions. And no antibiotics or growth hormones for livestock. No genetically modified ingredients. And no artificial flavors, colors, or preservatives. No sewage sludge or no radiation on the food. So organic foods not necessarily pesticide free. Just they can use some natural pesticides that are already approved. So that's the USDA organic seal by USDA. USDA has a program, it's a national organic program to reinforce the use of organic seal. And there are 3 different types of labeling regarding organic. So that 100% organic, it carries the organic seal. So it's 100% certified organic ingredients and processing aids. So all ingredients comply with national list of allowed and prohibited substances and certification required. The other organic label is organic. It's just organic with USDA organic seal. So it's 95% certified organic ingredients. So if a product has 95% of certified organic ingredients, so 95% of all its ingredients are organic, and it can have this organic seal. And non-organic ingredients must comply with national list too, and certification required as well. And also another may show up on label. It says made with organic. The USDA organic seal is not allowed. And they must specify which ingredients are organic. And even it's not like this is, it does not have this USDA organic seal, but still, if the product would like to mark with made with organics, at least 70% are certified organic ingredients. And non-organic ingredients also need to comply with national list and certification required too. And all organic, like with seal, without seal, and no GMOs in the ingredients. So sometimes we see natural foods. So natural foods is not the same as organic, because there's no formal definition of the use of natural on food labels that have been issued by USDA or FDA. But food manufacturer may use this term, even it doesn't mean much, but because there are no regulation. But when it comes to meat and poultry, the government actually regulate the term natural. But you don't see many of the natural meat or poultry, also very rarely. So for natural foods, it's the minerally processed foods, means it doesn't have much processing and do not contain synthetic ingredients. So there's no synthetic flavors, colors, or preservatives. And organic, they never have these artificial flavors, colors, or preservatives. But for the artificial fertilizers, pesticides, the natural foods may be used. And for the irradiation and GMO ingredients, also natural foods may use. So that's natural foods really don't mean much. But the only thing is, if they do go with like the true natural and there are no artificial ingredients. The environmental work group come up with this clean 15 and dirty 15 every year. This is for 2021. a clean 15, that is, these 15 foods have the least amount of pesticides, insecticides residuals, like avocados, sweet corn, pineapple, onions, papaya, sweet peas, eggplants, asparagus, broccoli, cabbage, kiwi, cauliflowers, mushrooms, honeydew, melon, and cantaloupe. Now, 3012 for the 2020, strawberries on the very top. So this group of fruits and vegetables usually have high residuals of pesticides and insecticides. So you want to wash and scrub fresh fruits and vegetables in this group under running water, and that can help remove bacteria and chemicals from the surface of fruits and vegetables. And peeling fruits and vegetables can also remove surface pesticides, but then it also reduces nutrients. So we usually just wash it very well, no need to peel. So that's also a question. Organic foods more nutritious than conventional foods? So that's the analysis. So there are no, like this is no difference. It means no statistically difference. So statistically, there are no difference in the nutrition panel of organic foods and conventional foods. The only two that's statistically significant are nitrogen. It's more in conventional foods, and phosphorus, it's more in organic foods. That's another study to look at nutrition panel of organic foods versus conventional foods. So the vitamins, organic foods may have more, so it's a higher amount of vitamins in organic foods, and higher amount of minerals, lower nitrate. This consistent with a previous study. Higher nitrogen in conventional foods, so lower in organic foods. And antioxidant activities, phenolic compounds, protein, amino acids, protein it's high in nitrogen. So protein, it's more in conventional foods, less in organic foods. But antioxidant activity is higher in organic foods. The other like beneficial fatty acids also higher in organic foods, but iodine and selenium, it's mostly from milk, it's lower in organic foods. It's the heavy metals, lower in organic cereals. And that's a myth that organic plant-based foods can offer estrogen, the extra cancer protection. And the truth is no need to just emphasize on organic plant-based foods. You just need to eat mostly plant foods. So plant-based diet, organic or not, reduces the risk of cancer. And that's the current conclusion on organic or conventional foods. Is that although organic foods may not have more nutrients per dollar. Yeah, when we look at it per dollar, because organic foods always cost more. So it's organic foods may not have more nutrients per dollar, and consumption of organic foods may reduce exposure to pesticide residuals and antibiotic resistant bacteria. So organic foods have less pesticide residues and less antibiotic-resistant bacteria. And there are no consistent difference in the level of vitamins and minerals in organic versus conventional grown produce. Organic fruit and vegetable may have more, like this, phytonutrients, antioxidants, phenolic phytonutrients, but per dollar it may not. So whether organic or conventional growth, fruits and vegetables, they're always critical parts of a healthy diet. And American Academy of Pediatrics issued a statement about organic food consumption. So that there's not enough evidence to support claims of clear health benefits from an organic diet. That's just say we want parents to provide our children with well-rounded diet, including a variety of fruits and vegetables. So whether organic or not, just plant-based diet and eat a good variety. That's the rainbow colors we showed previously. Now let's look at genetically modified organism, the GMO. So GMO foods, by definition, are foods derived from organisms whose genetic material, the DNA, it's the genetic material, has been modified in a way that does not occur naturally, like you introduce a gene from a different organism into this, into the food. So the technology is called recombinant DNA technology or genetic engineering. Currently, the available genetically modified foods mostly from plants. So in the future, there may be some animals. So that's mostly to improve yield. So the genetically modified crops, they are developed to improve yield by introduction of resistance to plant diseases and increased tolerance to herbicides, and probably improve yields and reliability. So that's the traditional plant breeding. The breeding is by cross breeding. So the bigger fruit, sweeter fruit, and after numerous selection, and pick one that's big and sweet. All it's do is like just to try to identify those in the nature that has been just like going through this sporadic mutation. So like, and the other type of plant breeding is by mutagenesis. So just to induce mutations in the crop, usually through radiation or chemicals. So agriculture is anti-natural because we manipulate what's in the nature by crossbreeding or mutagenesis. Now, GMO is a modern technology. Identify a gene of target or gene of interest, then extract this fragment of gene and insert it into the plant cell. And then you select the plant cell that has the gene of interest inserted, then clone and culture. It's become genetically modified crops. So it's just the DNA has inserted a fragment that come in from a different organism. So let's just say for the traditional, it may take thousands of years to get a desirable crop. But with the technology, it could take just much shorter time, like in months or years, we can get a desirable feature of a crop. So the traditional breeding, it's just this random combination of different, between different species. Or sometimes different, mostly it's different varieties of the same species. So then it's like that's the recipient and that's the desired. So you introduce desirable and undesirable genes. And for genetic engineering, I just cut out this fragment with desired gene and insert it into recipient DNA. So you only have the desired gene inserted in the recipient gene. So it's just like in the breeding, you have all sorts of unknown DNA inserted. This one only have the known desired gene inserted. So actually it's more accurate without unwanted characteristics. So why we grow GMO crops, already talked about that, insect resistance, drought tolerance, herbicide tolerance, disease resistance, and enhance the nutritional content, reduce food waste, improve manufacture process. These are the main crops, the GMO crops in the US. Most of you see this is like cotton, sugar beet, soybean, corn, canola, papaya, alfalfa, and summer squash. So the top 5, and most this that are like the commercial crops, mostly just for food processing, not for consumer consumption, right? Not for direct consumption. It's usually for like use as food ingredients or animal feed. And most of them have this insect resistant. HT, it's herbicide tolerant. AI is insect resistance. So that's what most of the GMO crops have, either the herbicide tolerant or insect resistant. Some have this drought resistance or virus resistant. Virus resistant was in papaya. And how we generate insect resistant GMOs. So this insect resistant gene is from the bacteria in the soil. So you cut out the DNA from the bacteria in the soil with the insect resistance. So then you insert this BT gene from the bacteria into the fruit. And then going through this genetic modification, the genetic engineering, the BT from the bacteria, now it's in the fruit. So the fruit now has insect resistance. And herbicide tolerant crops, it's the most common herbicide tolerant crops are Roundup Ready. So Roundup has this ingredient, glyphosate. Glyphosate inactivates an enzyme in plants to prevent them from being killed. It's the glyphosate inactivate an enzyme in plants. Because the enzyme is essential for plant to grow. And then when we apply the glyphosate, then the plant is killed because the enzyme essential for growth is inactivated. And Roundup Ready seeds, it has DNA inserted. The DNA, the inserted DNA, it has the that enzyme. It's resistant to glyphosate. So then, if the HT, the herbicide tolerant crop, it's not going to be killed when apply a glyphosate containing Roundup. So then farmers can spray herbicides in their fields, only kill weeds, because weeds has this enzyme will be inactivated by glyphosate, but the crops, the HT crops, has this resistant form of enzyme, so it will not be affected by the Roundup spray. So that's always concern of safety of herbicide glyphosate. But glyphosate, has very low toxicity, so that's to human and animals, because the glyphosate only inactivate the enzyme essential for plant growth, so it has no effect on human or animals. And glyphosate does not pass through the skin, so it does not go into our body through skin, and that's pass through the body rather quickly if accidentally injected. And glyphosate in the environment has much lower impact than the other chemicals. So they used to replace those with high toxicity herbicides. Then they also bind to soil tightly, so it's not getting into groundwater because it binds tightly to soil. Okay, so the GMO regulation, it's by the 3 departments, like by US Department of Agriculture to make sure it's safe to grow, and Environmental Protection Agency, the EPA, to make sure it's safe for the environment. And US Food and Drug Administration, it's regulate GMOs to make sure it's safe to eat. So all 3, the government agencies work together to make sure a GMO crop is safe to grow, safe for the environment, and safe to eat before coming to market. So that's a very strict, vigorous review processing. It costs a lot of money. So that's how a GMO potato from farm to our dinner table. So first going through vigorous review, and then the crop, it has better yield, less use of pesticides, and also less acrylamide, the carcinogens upon heating, and also would reduce food waste, because GMO potatoes has less browning effect. So GMO safety, that's for the consumer health. So the research across the world has found that no relationship between GMOs and mutations in the fetus, and it have no impact on organ health and function. And there are no evidence for gene transfer between GMOs and consumers. So that safety and toxicity, it is no much difference compared to the conventional foods. So it just appears that GMOs, as a class, are no more likely to be harmful than traditional bred and grown food sources. So that's the GMO DNA. because the GMO basically is just the DNA that's foreign. So the DNA, the foreign DNA in the GMO food, when it's consumed, injected in the human body, but it's where it's going. So the DNA, it's being damaged, degraded during food processing. And in our digestive tract, it's further digested and degraded. And some may be used by the intestinal bacteria. So mostly just excreted out in feces, like in pieces, not just a whole, not an intact fragment, but just like it's a breakdown, it's being damaged and broken down. So for the GMO crops, they're mostly used for food ingredients, like during food processing. So that food ingredient used in GMO, like within GMO foods, usually cannot detect the DNA in the food using GMO ingredients. The GMO crops, we're talking about the DNA. So the DNA is not detectable in packaged foods using GMO ingredients. So GMO DNA is as safe as any other food DNA. We have been consumed foreign DNAs from food. Like when we eat meat, we consume the DNA from animals. And when we consume vegetables, we consume DNA from the plants. So we have been consuming foreign DNAs. And the DNA will be degraded in the food processing and in the digestive tract. So it cannot encode protein because in the GMO food, where it's inserted, it's a foreign DNA, but what has the effect or impact, it's the protein encoded by the DNA. So then when we consume GMO crops or any other foods, the DNA that's capable of encoding full-length protein has been deactivated, degraded and deactivated. So no need to worry about a protein coming from the foreign DNA. And DNA inserted or integrated into gut microflora or human cell, it's minimum. And that's right to talk about it. They're using the recombinant DNA techniques, the genetic engineering. Actually, the genetic changes to a crop is more predictable than the traditional breeding techniques. So it's more predictable because we know exactly what we inserted into the DNA. So DNAs from GMOs is considered as safe as any other DNA in food. And there's some myths regarding GMO seeds, like seeds from GMOs are sterile. That is not true. They will germinate and grow just like any other plant. And most seeds these days are genetically modified. Actually, very few are genetically modified. Got just a few main crops like corn, soybeans, some potatoes. So, and a lot of the GMO crops, they're already created and approved, but not commercially available. And any contamination with GMOs made organic or non-organic, there is not a single documented case of organic farmer losing organic certification due to a contamination from a neighboring GMO crop. So that is, and the seeds, they are usable. You can reuse them too. But it is But nowadays, all the crops, they are already like been crossbreeding, so it's better to use new seeds anyway, GMO or not. So now lastly, we are going to talk about heat transfer in food cooking. So for the heat transfer in food cooking, conduction, that's what we like feel a hot handle. Convection is we feel a hot air, and radiation it's the also it's like can feel it from far away, like from the fire or from the sun. You don't need to be like very close to the source. And for that, this is an example when we cook a pan of water, there will be conduction in the handle. Convection is the water circulation, the hot water arise, and then the cold one would just down to the bottom. So that's a circulation. It's in liquid convection of the air. And radiation is you can feel it and you stand nearby. So radiation is the direct transfer of heat from its source by wave or energy, and this radiant energy called electromagnetic waves to the surface of food. So this is the heat source, and this is the electromagnetic waves, and the food absorb the heat. Like this, the oven use infrared radiation, and microwave using microwave radiation, and this is the irradiation. That's the sun. We actually get a lot of infrared radiation from the sun. And that's the whole spectrum. On the left side, it's high energy. So it's ionizing radiation. That's what we know as harmful to the skin, to the cells, like the gamma rays, ultraviolet, UV light. So these are ionizing radiation. On the right, these are the lower energy, longer wave. So the wavelength becoming longer, but the energy has like not as intense as the left side. So these are the non-ionizing radiation, like infrared, microwaves, radios, and our cell phones use this non-ionizing radiation with lower energy levels. And visible light is right in between. Now, when we use microwave radiation, we use the low energy radio waves. And the microwaves are refracted by metal wall of the microwave oven and absorbed by food. It causes the rapid vibration of dipolar molecules like water, fat, and sugar, and produce heat that cooks the heat. And the heats come within food. So heats within food, not on the surface. The advantage are safe and easy to use, quick and inexpensive. Disadvantage is like the temperature is not high enough, so it won't get a browning effect. And that could cause uneven heating, so you always need to stir after microwave heating. But these disadvantages actually are advantage when it comes to health, like less browning effect, less heat, will be less harmful chemicals produced. So microwave oven is a good way to use, especially for like children, because it's safe and easy to use, and no need to worry about the radiation because it's non-ionizing radiation, so it's not radioactive. And radioactive, like this irradiation, radiation, it's radioactive, but it's only use radioactive source. So treated with radiation or irradiation on the label, but the food itself does not come in contact with the radioactive material. So food does not become radioactive. And consumers always have this misunderstanding that food may be radioactive, so that's not true. And because of the consumers about the radioactive for the food, so all the foods treated with radiation must be labeled, both packages and whole foods. So that's the label, like treated with radiation or irradiation. So usually it's used to as like to preserve food, the fresh foods, by killing microorganisms on the like this on a strawberry. So help to preserve food with longer shelf life, and foods that are irradiation treated can be stored at room temperature. Like sometimes you see some of this liquid food actually stored at room temperature. It's because it has been treated with irradiation. Okay, that's all for today. Let's take some questions and the post-class quiz. Thank you.